Welcome to the System Architecture section. Let me be clear right from the start. This is the most important section in this course. Most of the work of a software architect is designing the system architecture, and you will find yourself using the concepts we will discuss in this section in almost all the systems you will work on. You probably already know by now that the main goal of the architect is to design a system that is fast, reliable, and easy to maintain. These qualities are translated to a system that is designed using the concepts we will discuss in this section. But before diving in, let's talk about the meaning of system architecture. We already talked a lot about components architecture. We talked about layers, logging, dependency injection, and more. With system architecture, we take a higher point of view and we look at the big picture. And in the big picture, we usually ask ourselves these questions. How will the system work under heavy load? What will happen if the system will crash at this exact moment in the business flow? How complicated can be the update process? And more. These are the main questions. Of course, there could be more depending on the specific requirements of the system. Now, the answers you will give to these questions will vary, depend on the system. For example, you might decide that a system crash is tolerable since the data is not sensitive and there are not many users, and so the system should not be redundant. On the other hand, if the system is mission critical and no data should be ever lost, plan for a massive system with a lot of queues, as you will see in the next sections. The system architecture includes the following aspects. 1. Defining the software components or services that together compose the system. 2. Defining the way these components communicate with each other. 3. Designing the various capabilities of the system, namely scalability, redundancy, performance, manageability, and more. In this section, we will focus mainly on the second and third aspects, since we've already covered the software components themselves in previous sections. The topics in this section are loose coupling, which talks about the way to make our components independent from each other. Stateless, a pattern that allows our components to scale and makes the whole system redundant. Caching, a technique that helps improve the system performance. Messaging, which is a discussion about various techniques for passing data between services and there's pros and cons. And logging and monitoring, to make sure our system will be able to report its status and avoid surprising failures. So first, let's talk about loose coupling.